Hey guys, all right, we are on page 41 and we are doing the final boss. So this is just putting it all together, integrating all the different things that you've learned. So let's warm up with a basic skill. It says, given that 4 sine x plus cosine x equals 0, show that the tangent of x is equal to negative 1/4. So this is a show problem. That means I'm just doing some algebraic manipulation to get this to equal this. Okay, so I would have 4 sine x plus cosine x equals 0. So I'm going to move over the 4 sine x. And then now I am going to divide both sides by the sine of x. And I get cosine of x over the sine of x is equal to negative 4/1. And then I know that cosine over sine is cotangent, which is 1 over tangent. Therefore, tangent, I would flip these and flip these. Tangent of x is equal to negative 1/4. So for example 1, it says we can use Pythagorean quotient or reciprocal identities and double angle formulas to rewrite scary things in trig equations. And this helps us put them into a less scary version that we can solve. So continuing from the do now, part B says, hence, find the values of x in the interval from 0 to 360. Okay, so we're in degrees, so let's make sure our calculator's in degrees, all right? For which 4 sine x plus cosine x equals 0, giving your answers to one decimal place. Okay. So it says continuing from the do now. So that means I'm going to take what I found in the do now, the tangent of x is equal to negative 1/4, and I'm going to start there because I know that he is an equivalent representation of this guy. So I have the tangent of x is equal to negative 1/4. And I'm looking for the solutions on the interval from 0 to 360. One full rotation. Okay, so if I am looking for where the tangent of x is equal to negative 1/4, I am going to use my knowledge of where things are positive or negative in the coordinate plane and decide where my solutions are going to be located. So I'm looking for where tangent is negative because this guy is negative. So I'm going to eliminate quadrant 2, quadrant 1, or no, I'm going to eliminate quadrant 1, quadrant 3, and I am going to keep quadrant 2 and quadrant 4. Okay, so my solutions to here are going to lie in quadrant 2 and quadrant 4. So what I'm going to find here is in my calculator, I'm looking for the inverse tangent of negative 1/4. And I would get negative 14.0362. So I would have x is equal to negative 14.0362 degrees. That is my reference angle, okay? And I'm going to use my knowledge of reference angles to figure out what these actually look like. So in this quadrant 2, I have 180 minus the reference angle. And that is going to give me oh, it took the negative as well. Hold on, let's get rid of that. 165.964. And then 3 sig fig, so that's going to be 165.9 becomes 166. Okay, and then let's figure out what it looks like in quadrant 4. Excuse me. So in quadrant 4, I'm going to do 360 minus the reference angle. And I have 346. And those are the two values of x on the interval that they outlined above. Now I have to show that 5 sine squared x. Oh, this is a different question. Thank goodness. I was like, this looks very complicated. Okay. Example number 2, this is a different example. It says, show that 5 sine squared x plus 5 sine x plus 4 cosine squared x equals sine squared x plus 5 sine x plus 4. Okay, so I see a lot of sines, many, many, many sines, and only one cosine, and he's squared. So that means I can turn him into a sine. So I'm going to do that because then I have everything in terms of sine, and I can kind of figure out what's going on here. So I'm going to use the Pythagorean identity, that sine squared x plus cosine squared x equals 1, to rewrite cosine as sine. So I'm going to rewrite I have the cosine squared x can be rewritten as 1 minus the sine squared x. Okay, good. So I'm going to use that right here. I would have 1 minus sine squared x. He is the rewrite of that guy. So let's copy all the stuff around it. There's a 4 out front. And it looks like I'm just manipulating the left-hand side, so I'm going to get rid of the equal sign for now. I'm trying to match the left-hand side to become the right-hand side. Okay, so now I'm going to distribute this guy. I'm going to combine like terms. So I have a sine squared x here, and I have a sine squared x here. So I would end up getting sine squared x plus 5 sine x plus 4. Oh, yay, I got it. Equals sine squared x plus 5 sine x plus 4. Perfect. And then for B, it says, hence, find the values of x on the interval from 0 to 360. Okay, so we're in degrees again, where this original piece, 5 sine squared plus x plus 5 sine x plus 4 cosine squared x is equal to 0, is the equation that we're solving, and it says giving your answers to 1 decimal place. So I'm going to use this much more succinct rewrite that looks quadratic, so I already have an idea of how I'm going to solve this guy in place of this nasty equivalent expression over here, okay? So I'm going to set that equal to 0. Now I'm going to search for the solutions on the interval from 0 to 360, so 1 full rotation around the coordinate plane. All right, let's factor this guy. So if I want to factor a quadratic, I'm going to use u substitution. I'm going to let u equal the sine of x. So now everywhere I see a sine x, I'm going to put in a u. And I'm going to factor. Okay, so now I'm going to do my substitution, right? I let u equal sine of x. Now let's let the solutions equal the sine of x. And right off the bat, I see that this guy is out of range. What do I mean by out of range? Well, a sine function is sandwiched between +1 and -1. Therefore, a plain old sine curve is never going to equal -4. So we can go ahead and reject this solution because he is out of range. And let's zero in on the sine of x equals -1. So the sine of x equals -1. He's going to be a quadrantal angle, which means he's located right on one of these 4 axes. This is 0, this is 90, this is 180, and then this is 270. This is 360, back to 360. So when we have sine of x equals -1, remember, on the coordinate plane, x is cosine, y is sine, y is sine. So I look on my unit circle, and the coordinates of this guy would be 1 over 0 up, this guy is 0 over 1 up, this guy is -1, 0, and then this guy is going to be 0, -1. So sine is -1 at 270. Or if this was a calculator question, I don't remember if it was or not, you can just type it in. So you're looking for where the sine of x is equal to -1, so inverse sine of -1, and you would get -90, which is 360 minus 90, and that's going to give you 270. Boom.